She's going regular algebra.
Yeah, see, that's the problem.
Good, how are you?
Yeah, dude, you literally hate it. Yeah, like fourth grade. I know. And then y'all did it.
Hasn't got 100 done with that. I got a half point.
Half a point.
Because I didn't put no poo date, I just put instead poo date. She said she can get it. And we have a paper that's due Tuesday.
Is it a lot or?
It's a project. I got some of it done.
taking a break? None of you do? Why don't you go take a break? Oh, you just got in here. You just got here. Sorry, I forgot he had planned last turn.
A Brady lead.
I'm not sure you go after this
Hello, everybody! Wow, the energy again, you guys. Gotta calm down a little bit in here. All right. Hello. Oh, there's somebody coming in my classroom. Let them in. Okay. Boom. Shoo-doo-doo-doo. Let's turn on. That's on. That's good. Did I give you guys these answers yesterday?
No.
I didn't?
Oh, you're here to sit up before you did.
Yeah, and I forgot to hit post last night. I loaded it up and I didn't, so it's not there. So I'm just going to put them up on the board, the answer, the actual one that has all the work. I'll put that on the board, turn the lights off, and we will take a look at that. And then we'll take care of any questions you might have on these beautiful questions. Make the lights here. And word problems in general, you know, I always solve mine exact first. Like I get to this point, and then I go ahead and give the approximation because of a word problem. You want something that makes sense, okay? So have you guys checked over these? And while you're doing that, I'll take attendance. This. Log in here, log in there. Okay, that's fine. So I know those two are doing the ACT today. So she's doing ACT here. My Noah Owen is going to be good. Noah's absent. Okay. Boom, that's fine. Stacy's here. Mine. And True. Okay, submit that. Should probably do. Ah! Oop. Let's just do that all. Shoo-ba-doo-ba-doo. That's the chart. Perfect. We did 5 together in class, I know, yesterday. We kicked through all of that, so. So here's what I want to ask you guys to do on that sheet of paper, somewhere on the top. Scale of 1 to 10, where do you feel you are with word problems? Scale of 1 to 10. Okay, 1 means you can't find my room. 10 means you could teach the class. Okay, where are you on the word problems? Do, do, do. 15. Okay. 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 Shall do, 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 do. Do, do, do. All right. So if you were going to tell me where the struggle is in general, is anybody willing to tell me like where they feel like their biggest struggle is on the word problems?
Going from like exponential to continuous exponential.
What's that again?
Going from exponential to continuous exponential.
Oh, okay. So changing over to a continuous function. Okay. Anybody else want to say like what would be the thing that maybe is hardest for them? You don't know? At least that's something I can focus on. Yeah.
The half-life ones.
The half-life ones. So I think I gave you 2 half-life problems, right? So what about, okay, so Ryan, I'm just going to ask you since you said that. Number 3, the first part, were you okay with the first part or not?
For 3?
Yeah.
No.
No. Okay. What about number 5, the first part? Where you had to just write the function.
I could do that.
So you're okay, you understand what the function says, and you can fill in the spots on it, you're saying. Were you okay with the second part here? Like the 5 grams? Okay. Alrighty. Do you have trouble going to the continuous? All right, so that's kind of the same idea then. Okay. So let's talk about that a little bit. Let me go ahead and get out of this. Okay, where in the world are you? Well, that's not. So let's just talk about that in general. Half-life model is this. I'm going to use T over HL. Okay. So we all understand A is the initial amount, T is how much time has passed by, HL is how much time needs to pass by before it reduces by half, right? That's what the half-life, okay. The continuous version of that, right below it, would look like this. Okay? Now, so when you're looking at these are the same, those have to be the same, right? Here's where things look different, of course. All right, so what I want to do is I want to take this, I'm going to move this over here, and I want to rewrite this as, this part right here is what I'm concerned with. This is the same as 1/2 raised, now this, I want to factor this. There's 2 ways I could factor it, okay? I'm going to factor it so the T is on the outside. So I'm going to put this. So let's think about power of a power property. Okay? Power of a power property, if I remultiply these, I'd be right back where I started. So this is the same as this. I'm going to do the same thing here. This would be E to the R raised to the T. So are we okay with that? Okay, so look at this thing. What's being raised to the T? This. What's being raised to the T? This. Right here, then, this tells me that E to the R is equal to 1/2 of 1 over HL. All right, now I'm going to keep going with this. Because I want you guys to see there's just this is always going to be the same with the half-life ones. Okay? I want to solve this for R. If I'm turning it into a continuous, I would have to solve this for R. All right, great, here we go. How do I solve this for R? I would have to change it to a logarithm. It's in exponential form, we ran it as a logarithm. So here we go. R would be equal to the natural log of 1/2 raised to the 1 over HL. Now, do we understand that? That's my question. You're okay with that. Ryan, are you okay with that? Now, is anybody else got a question about what I just did? All I did, literally, it was this. It's this idea right here, guys. If I gave you this and said change it to a logarithm, this would be the natural log of b equals r. It's the same idea. This is the natural log of b equals r. This time, b is this entire thing. So it makes no difference. Watch now what I'm going to go ahead and do. Properties of logarithms. This exponent is allowed to go in front. Okay? Guess what this becomes? That's always going to work on the half-life models. Always, always, always. If you want to take a half-life model and change it to a continuous, R, the continuous decay rate is always the natural log of 1/2 divided by the half-life. Every single time. Okay? So what I'm telling you is this. If I gave you a half-life model, and I said, y equals 500 times 1/2 raised to the t over 68. And I said, change this to a continuous, I immediately know that r is going to be the natural log of 1/2 divided by 68. Every single time, it's going to be the natural log of 1/2 divided by whatever the half-life is. And immediately then, I can just go ahead and write my function, whatever it is then. I would go ahead, I could get the decimal equivalent of this if I wanted to, and plug it in, and boom, I'm done. Right there. Okay? If you remember that, that's great. If you don't, you can always get there. You can always get there because of this idea right here, guys. Okay? Does that help at all with that? Yeah? What else? What else, guys, do you think that might be the stumbling block if you're having something? This is where you got to be honest. You can't be afraid to say something because I can't help you otherwise. Is it let me ask you this. How many of you thought these problems were harder? Did anybody think these were harder than the previous ones that I gave you? No? Okay. Yeah.
Could you do the second part of 3?
The second part to 3. Okay, so number 3. Oh, sure. Here we go. So once I have this, that's weird. That's not good. Oh, it's because I didn't even notice it was there. Look at that. Okay. So once I have that, let's go ahead, just get rid of this for right now. The half-life model then, if I wrote the half-life model, since this is the half-life, would be y equals 84 is the original amount times 1/2 raised to the t over, that's the half-life. I want it to be continuous. So the first thing I have to do is find out what r is. What's r going to be? The natural log of 1/2 divided by 113.584. Then that you have to do on a calculator or on Desmos to get an answer. So we'll do it. ln, natural log of that, divided by 113.584. That's what I got this time. I don't know if that's what I had last time or not. I just erased it. So what do I get then? That's r. So now my continuous model then would be y equals, the starting amount's the same. Now it's in base e to the negative 0.0061 t. There you go. So that goes right along with what we just did.
Do we have a problem with Newton's law?
Can we do one like that? Sure, let's just make one up. Wait a bit about. Aha! Oh, let's see here. Okay, let's see here. There you go. Okay, boom. There we go. So he wants to be able to handle it without gloves, so he can put it out on the shelf and display it for sale. Okay. He's got a clay pot, pulls it out of his kiln. Got a temperature of 580 degrees. 10 minutes later, it's 535. It's safe to handle without gloves when the temp is 110 degrees. How much longer before he can handle it? And put it out on the shelf for sale. Yeah. Oh, we do! Thank you. Hey, the showroom is 75 degrees. That's where he's going to put it at in the showroom. He's going to set it out there. It sits in the showroom. No one can touch it. It says, "Do not touch." So how much longer before somebody can touch that and pick it up and look at it? Admire his handiwork. La, 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 la. And see how we did that. Let's check this. Delete, delete. Delete. Do goodbye. Well. screen on that. Okay. Okay. All right. Okay. All right. And let's. So okay. So think about it. You need to do this by itself. So first you can just simplify this to start. You're gonna be careful. Order of operations. This is kind of like 75 plus. Think of this as an X. Because even though this is a number, it's a variable. So what goes on? Are you allowed to 75 plus is this or negative 505? Can I actually name this? Correct. So if I were this team, I asked you to solve first for X, what would you do? You'd subtract 75, and then you would divide by. You do this the same way, and that's how you get this by itself. You're gonna lost, okay?
So, and this is negative, is that?
You want the negative. K in the end. Oh wait, this can't be.
Not the 505.
Oh, you don't subtract. This is not what multiplication is. See, if I do it by subtracted that, you divide this. That's being held on by multiplication.
That makes more sense.
Yeah. I'm just going to set this up on the left over here. Okay. So on this problem where I'm solving for K, what I need to do is I have to get this isolated. I have to isolate this. I need e to the 10k to be equal to something so I can go to a logarithm. Use logarithms, okay? So let's think of this. I'm going to do the following. I'm going to say let, might help somebody, e to the 10k be equal to the variable y. Everybody just stick with me for a second if you're struggling with this. So over here I would get 535 equals 75 plus 580 minus 75 times y. I want to solve that equation on the right for y. I would hope the first thing you would do is simplify the inside of the parentheses and make this 535 equals 75 plus 505 y. Okay, how do you solve that? What would be the first step? That's an Algebra 1 problem now. You would subtract the 75 from both sides. Okay, and here you get what? 460 equals 505 times y. How do you undo that? How do you solve this? Divide by 505. So y is equal to 460 over 505. All right. Y is really e to the 10K. Now I can do what? Change it to a logarithm. So that's how you do that. You have to view this as kind of like you have to get this by itself. So I would get the natural log of 460 over 505 equals 10K. Then what? Divide by 10. That's how you get your cooling rate on this problem. That's how you get it. Now you have to get an approximate for that one. Okay? So I need, what do you get approximately for K now? Negative 0.00993, you said? You guys, do I have confirmation on that? Yes, yes, yes. Okay, good. Now, that's the first step. Okay. Anybody want to ask anything on that one now? What do I want the temperature to be is the question. I want it to get down to 110 so my customers can pick it up and hold it without burning themselves. So I have to know how much longer does it need to sit in a spot where they can't touch it in the showroom. So now I have to go ahead and find out an amount of time. So this time I'm not going to be solving for K, I'm going to be solving for, which means I'm going to approach the problem in the exact same way as far as solving it goes. I'm just going to have to change some numbers in it, that's all. So let's write this new problem. Okay, I'm going to write it right here below it. Okay. So the second time I do this, I want the new temperature to be 110. What's the initial temperature though? It's the 535 because I want to know how much longer. So it's from this point on. That's where I'm starting at now. And then it's e to the, what I just found, negative 0.0093 t. That now is solved in the exact same fashion as the previous one was. Yeah.
So we do the rounded number for the K?
Say that again?
So for the K, we do the rounded number?
Yeah, this one I just did. It's fine. That's fine if you do that. I just want to see that you know, if you get to this point, then you know what you're doing. I'm fine with that. You just round it. It makes it easier to put it in your calculator later on, probably. So it's fine to round it. And I'll tell you what to round to, but that's good right now. Okay? Yes?
You don't round it, that's okay.
That's true. Yeah, it's fine. Because I'll know the answers are close enough. I'll be fine with that. I'll know what the answers are supposed to be. Yeah.
Can you also just change out the 110 and then just subtract 10 minutes at the end from your
You
final
could.
time?
Yeah. Yeah, there's multiple ways of doing it.
Yeah.
Mhm.
I just got divide by 10.
Say what?
I just got divide by 10.
You did.
Once you're all.
You did what?
I've got divide by 10.
Oh. Oh, that'll do it. Yeah. Okay. All right. So now everyone should be doing this. So we'll go ahead and get an answer for this. Approximate how many minutes is it going to take? So once you guys have answers to this, you have an answer, I'm sure, already. Okay. See that? Still going. Yep.
I'm still going.
Okay, you're still going. What are we doing? So then you get to see basically that green one now you're solving for G in the row. Yes, ma'am. You can. The ones you make is to help you understand how to get this by itself. So if you think that helps you understand that better, that's fine. I would just say to myself, hey, this is by itself. So I can say, so how do I get this by itself? I get this. I ask my
Says it's about 270.
Yeah, and then you go to the natural number. Did you get it? Yep.
I just didn't know
Yep, yep.
that's
A lot of people are getting it here. So it's so you did natural number. And then what do you want to do next? Oh, so you need to still design that. Because that's what, well, that's timed, right? Because, yeah. So now you can take this. Could actually go right here. Oops, go out here. Close there. And then just divide by. Negative. So you got 277.
It still gave you the same thing when I had to bring the other one.
Then that's fine. That's fine.
You put 110 equals.
You can't, you gotta have a function. This is gotta be y equals.
Oh, and you get y equals.
Then you do y equals 10 to get the intersection of 2 points, the intersection of 2 graphs. So a lot of people are getting there. I love it. So this is about anywhere from about 276 to 277 minutes. Okay. Depending upon whether you use that or you use the exact. All right. So does that make it a little better? Is that better for you then?
Yeah, thank you.
Okay. Anyone else want to ask something real fast? A general question about any of these? Or maybe it's not just about word problems. Maybe the struggle was more about just solving.
Could you do number 2?
Number 2?
Yeah.
What's number 2?
One of the half of
Oh, Mr. Shirley! All right. So here is the model we're going to use for this. Let's go ahead and. Actually, I did that one. Well, I'll gladly do it again. I don't mind doing it again. So when we read this one, it is a half-life problem. So immediately I know I'm using this model right here. So it says, Mr. Shirley, being a science nerd, he is, takes the bone to school and finds it retains 85%. That's the new amount. Now I have a choice. I could say that this is 85 out of 100. Now, if it's 85 out of 100, that means I must have started with 100. Or I could say it's 85%, which is 0.85, which means I started with 1. These are saying the exact same thing. So either my starting amount's 100 and my new amount's 85, or my starting amount was 1 and my new amount's 0.85. Equal, and then 1/2 times either one of those. T, that's what I don't know. And then I've given you the half-life was 5730. Okay, so if I'm doing this, doesn't matter which one, my next step on both of them is going to be 0.85 equals 1/2 to the T over 5730. Now it's a logarithm problem. I got to use logarithms. It'd be log base 1/2 of 0.85 equals t over 5730. Multiply by 5730, so t would be 5730 times log base 1/2 of 0.85. And then you just put it in your calculator. Now, I didn't ask you to do continuous on that one. If I wanted to, should we be able to? Yeah, we would have to just do what? Find the continuous rate of decay for carbon 14. And how would I do that? If I wanted the continuous rate of decay for carbon 14, how would I do that again? I told you how to do it. It's the what? Natural log of 1/2, always divided by the half-life, which is 5730. There it is. And then I could write my function and be done. All right. Woo. All right. Now this next problem I'm going to give you is going to be a challenge because we haven't done one like it. Okay? You guys ready for a challenge? All right, we'll see. Ooh, let's go to a full page. Okay. Here we go. There's two questions to the information. Oh, let's see here. Let's pick something that's not too nasty. I'll try to be nice. How's that sound? Oh, I like that one. That's a good one. There you go. That's a good one. Yep. Okay, given the points, there they are. Those are ordered pairs, right? 1. And you can do that in slope intercept forms fine, okay? So I'll just put SIF, slope intercept form. 2. Oh, you can do that when you come back. There you go. That's what we're doing. Try that out. One of those you've done in the past, we just haven't done it this year. I'll be out in the hallway, relaxing.
Is there a I got a half point off, and then Evan got 100 on it, so I'm not sending it out. You do Quizlet flag for
sometimes Sam, I don't know if I can get your
Number one. Have a beautiful problem.
unless you want to stay.
One's really not that bad. I mean, it shouldn't be. Even though it's got fractions up there, it ends up being pretty nice. There. Can anybody tell me what the first step on one is? Huh? Find a slope. And of course, I said I want this in slope-intercept form. You're here from last Friday. So right now, make sure you got the slope right. Make sure you got the slope right.
Oh, we got doesn't change
Happy birthday.
Thank you.
It's your birthday?
Yeah.
Happy birthday.
Did you see the sticker?
Stickers down there on top. Okay, so we're finding the slope, which is the change of y over the change of x, and the slope is also called, by the way, I really and truly hate calling it slope. I hate it. I like calling it rate of change. It's really the average rate of change is what the slope is. It's the average of change. But anyways, it's the change in y. So for this one, I could do 9/2 minus 1/2 over 2 minus 0, which of course is 8/2, which is 4 over 2, which is 2. Boom, done. Child's play. So now I have m. So I have to find b. Now b is the what?
The y-intercept.
It's the y-intercept. Where a graph crosses the y-axis, the value of x is what? 0. So I gave it to you. It's right there. Okay? So the equation here would be y equals 2x plus 1/2. End of story. Okay? Now, down here it says find the equation of an exponential function passing through the 2 points. Okay. So the general form for an exponential is y equals ab to the x. Now look, in this equation here, this is the y-intercept or the initial value. Down here, it's not the b value, it's the a value. This is the initial value. So I know already what a is. A is what? It's 1/2. It's right there. See it? Okay? I know it's 1/2. Now, before I go any further, though, I'm not even going to put that in. I said that to you, but that's not what I'm going to do first. Here's what I'm going to do. Okay? I'm going to write 2 equations. Because what I need to do is find not the rate of change. I have to find the factor, b. The growth factor or the decay factor. I need to find the value of b. Here's how I'm going to do this. I'm going to write 2 equations, and I'm going to replace, I guess I will replace them all, but I'm going to replace y and x with values I have up here. Does that make sense to you? I'm going to leave it in terms of a and b, okay? So my first one, I'm going to make it 1/2 equals ab to the what? ab to the 0. And the second one below it is going to be what? I'm just putting in my points. 9/2 equals ab to the second. Okay. Now, when you have 2 equations and 2 unknowns, that is called a system of equations. I'm going to solve this. It's a system of equations. Now, here's what I'm going to do. Okay? I have a choice when I'm doing this. I'm going to go ahead and take this, either equation I want, but I'm going to take this top one up here. This guy right here, this 1/2 equals a b to the 0. And guess what I'm going to do for it? I'm going to solve it for what? I think I should solve it for A. I'm going to solve it for A. Boom. There it is. Let's solve this for A. What do I get? How do I solve this for A?
You could start by simplifying because anything to the 0th power is 1.
Okay, so I know that's 1. Okay, great. So now I've got 1/2 equals A times 1, which means A equals 1/2. Well, now we knew that. That's great. How does that help me? I could do what? Plug that into my second equation now and solve for B. 9/2 equals 1/2 times B squared. Now what do I do to solve this? Divide by 1/2, which is the same as multiplying by 2. So I'm going to multiply both sides by 2 times 2. On the left, I'm going to get 9 equals. On the right, I'm going to get b squared. Take the square root. Since I'm finding the base, bases must always be positive. So I don't need the positive and the negative root. I only want the positive. So what's b equal? 3. So what is the exponential that passes through those? Y equals 1/2 times 3 to the, boom, did it. Okay? So if I gave you 2 points, you could write an exponential through it, you could write a linear. Okay? Given 2 points, you should be able to write either a linear from Algebra 1 or an exponential that would go through those points. Okay? So let's just try another one. Now that we've done one like this, let's just try another one, okay? Does anybody have any questions on what I just did down here? So I wrote 2 equations. I did kind of a system idea here. All right, we're going to do another one here. I've got it right here, okay? I want you to find an equation y equals a b to the x that goes through the following points. And 3, 1. All right? Try this one. So I didn't give you the initial value on this one, by the way. I didn't give it to you.
What's your plan?
Hmm?
What's your plan, period?
Second.
Second.
Yeah. Oh, do you need somebody to cover something?
On Zoom,
Mhm.
there's the feature that you can look through your document count. Have you used it?
I think last year I should have sometimes.
So it looks fine on my end. What I'm displaying, so I'm displaying it on the board for my kids.
Right.
The kids that are watching at home on Zoom, it's what?
So there's a setting. If you go in here, like this, if you right here, because I have a Zoom going actually.
Sorry.
If I go into video settings here, mirror my video,
Okay.
that means their video should flip.
Video settings.
Video settings,
Should
and
we
then
do
it
it
should,
again?
so all I did was I clicked on this and go to video
Video
settings,
settings under the stop.
and then mirror my video should do it.
Okay. The girl was telling me yesterday, I'm like, I don't know what to do.
Yeah, that should work for you.
Okay, thank you.
Yep. Okay, is this one harder? No? No? Okay. I'm not gonna solve it yet. I just need somebody to give me what's one equation I should write? Who can give me one of my equations I need to write down? Yep. Turner? Yeah.
T equals A times B squared.
Say it again.
2 equals A times B squared.
Okay. I thought you said T.
I did say.
That's what I thought you said. I was like, T, what? Okay. Yeah, there's one of them. And the other one is, of course, what?
1 equals A times B.
Okay. Now, first thing you should be able to tell me, is this going to be growth or decay? It's going to be growth or decay. What do you think?
Okay.
Decay. Why do you say it's decay?
When I graph the points there, it's linear line is also.
Look what's happening. As x is increasing, what's y doing? Decreasing. That means it has to be decay. Which means my value of b better be less than 1. I'm just thinking ahead on my own, saying, okay, now I know my answer better be less than 1. If I get an answer that's not less than 1, I've done something wrong. Okay? So, here we go. Now, there's a lot of ways of going about this problem right now. Okay? But what I need to do is I need to take one of these equations and I'm going to solve it for A, like I did the last time. The difference is this time it's not going to give me the value of A yet. I will tell you right now, I will always choose the one with the B that has a smaller exponent. Always. And I'll show you why in a second. All right? So I'm going to take this one and I'm going to solve it for A. And that's easy enough. All I do is divide by B squared. So I get A equals 2 divided by B squared. Now I take this and I substitute it in place of A on the second equation. Because A can be replaced with 2 over B squared. So I do that right here. 1 equals 2 over B squared times B to the third. What do I get on the right-hand side now? What do I get? You could say it's 1. If you need to do this, guys, to think it through in your head, that's fine. But what do you get? What's that going to give you? 2b. 1 equals 2b. Oh, great. Now I need to solve that for b. Right? How do I do that? Is that right, what I have there? No, it's not 2 over b, it's 2. You guys gotta stop talking. Some of you guys are way too quiet. So what's b equal? B equals 1/2. Now guess what I do? Now I take that and plug it into that first equation in place of b here to find out what a is. Now it's just simplifying that. A equals 2 divided by 1/4, which is what? 8. So now I can write my equation. Y equals, is this my initial value? Yes, 8 times 1/2 raised to the x. All right? There we go. Now, I said I always take the smaller one and solve for it. So let's go split real fast. Let's go here. Let's go here. Okay. So if I go back to this 2 equals ab squared equals, and if I do this one and solve it for b, or for a, I get a equals 1 over b cubed. And then I plug it in here, I get this. I get 2 equals 1 over b cubed times b squared. Why is that not as nice for you guys? And you can do it this way, you'll get the same answer, but what happens here? You get 2 equals what? What do you get here? 2 equals what? 1 over b. Do you guys like having the variable in the denominator? Probably not. That's what happens if you do it that way. Now, I do know, though, all I have to do is multiply both sides by b, and I get 2b equals 1, so b equals, I mean, I can get to it. I just create maybe more of a headache for myself, but it gets me there. Shouldn't make any difference. All right. Now, if I wanted to, here's a question. What if I had decided on this original one up here? I'm going to go back to this and add a new page in again. And I'm going to put these down again. 2 equals ab squared, and 1 equals ab cubed. What if I decided I want to do this the harder way? Because there's usually an easy way and a hard way. I mean, I could choose the hard way. I could say I'm going to solve this for b instead of a. What would this be? Let's see. B squared equals 2 over a. B would equal the square root of 2 over a. Does that look like fun to jam in the other one all of a sudden? Because then look what happens. I plug it in over here. I get 1 equals a times 2 over the square root. I'm sorry. I get the square root of 2 over a raised to the 3rd power. Are you liking that as much? No, of course not. You don't want to do that. You want to solve for a because a is to the 1st power. You don't have to worry about taking any roots for it. So don't solve these for b first. Always solve for a first. And you want to solve for the one that has the smaller exponent with b. That's my advice to you. All right? That's my advice to you. So now we're going to try one more. One more. I know I have another one here. All right, here we go. Woo! Do the following 2 points. There you go. Try this one out. You think you have an answer? If you want to solve for one of them, and tell me what you got before you move on. So you're going to be solving for B first on this. Okay. Doesn't have a B value yet. Try this one. So what are you going to do there? Just tell me. Don't cheat me. I got a brain. Okay? Yes. I'll do that. I want that. Yeah, that's good. Yeah. Yep. So here's your, you solve for O.
That one was too up.
Oh, okay. I'm just gonna. There it is. Okay. Very nice. All right. So you're just going to be, I'm going to give you like 3 problems to try over the weekend like this. That's it. Okay, this is like the last thing we're doing with exponential functions that's new. Then when we come back on Monday, we'll go over these 3 problems I'm going to give you. We're going to do a couple word problems again. And then I'm going to give you guys kind of like, and it's not a little, it's a challenge problem. A definite challenge problem. Okay? Then on Tuesday, we will start getting ready for the test. I will give us a review for the test to see how we're doing, what we need to focus on. And then on Thursday and Friday, we will take the test on 2 separate days. That's because we have shortened periods next week because of scheduling. So they're 35-minute periods instead of 40. So what we will do is on Thursday, you'll have both periods to do the non-word problem part of the test. And then on next Friday, you'll have both periods to do the word problem part of the test, so you have plenty of time for it. So we'll do the test over 2 days, okay? So you have plenty of time to get it taken care of. Does anybody want to ask a question about that problem I just did? Are we okay? You okay? All right. Let's go back to a single page. I will post this online for you guys. Let's just do this. Let's just do this here. Okay, so I'm going to give you 3 problems. 3. So for all of these, you're going to write an exponential y equals a b to the x. And let's see, the first one, I think it should be number 2. Number 3. Which of these do I want? I like them both. Just don't know which one I want. They're both so nice. Let's do this one. There we go. Those 3. That's it. And you can also be looking over anything else you need to be getting ready for the test. You can already start studying, and maybe you can have questions ready I can answer for you next week too. Who knows? Start looking for your questions, putting them on paper so you don't forget what they are. Excuse me. You want a Jeff one or what's that? Which one are you on?
The first one.
First one here, 327. I don't think you should have to round on that first one. Okay.
Oh, I corrected the runner.
That's okay. That's why. I was to say it should not be.
Yeah.
Should be nice. Got it? Excuse me. Channel.